And this presentation, all yours, sir. Are you ready?
Yes, I'm ready. Good morning. Thanks for attending this pre-ISSS tutorial. This is actually like a four-part. There's two main parts. There's the first half is from 9 to 12. Then you take an hour lunch break. And for those who want to come back, then the second half is from 1 until 4. The title of this is Space Hazard Analysis, first component of high dependability for small unmanned spacecraft. If you come to this course, I assume everyone here has experience in space systems. So, we don't have to go through those details. However, you may not have very much experience in space hazard analysis, at least not the way it's supposed to be done. So before we start, any questions, aspirations, objectives? Does anyone have any specific things that they're interested in before we get started? Yes, one.
The artifacts that are produced as a result of the analysis.
You asked about artifacts? You say
All the documentation produced.
in order to do this? Yes. Actually, as you go through this, you'll be asking how come there's so much documentation. Okay, so yes, that's going to be covered in detail. The artifacts actually at every stage of the life cycle, that's going to be covered. Also from the not only the contractor's perspective, but the customer's perspective. So if anybody here is government, whether it's U.S. government or otherwise, right, you definitely need to know what artifacts to ask for and what they should contain in order to make sure. Yes?
Are you going to talk at all about software hazard analysis or mission critical software versus safety critical software as it's applied to small spacecraft?
Yes, I am. Okay, so the purpose of the briefing is to facilitate maturation of the commercial small unmanned spacecraft industry. Now, there's a military spacecraft industry, then there's commercial, okay? We want, at least I want, okay, the commercial spacecraft industry to actually mature a lot more further than what it is. And actually the military can actually facilitate that and benefit, both can benefit from that. And the details I'll talk about later, okay? There's something called capability-based safety, reliability, quality assurance. For those who are familiar with capability-based processes, I don't have to explain to you what those are. For those of you who are not familiar with the term capability, because it's not performance-based, capability-based and performance are different. Capability processes are actually a form of pre-tailoring where there's a structure to tailoring something to meet whether the mission, the product, or the cost. And there's a whole set of standards, the AIAA standards, that are based on that. Okay, so that's going to be part of this, is to talk about this in terms of capability-based processes, and they're standardized. These are all standardized processes, okay? The other thing is, for those of you who are associated with the U.S., and I don't know, maybe foreign countries have the same thing, but there's something called Urgent Capability Acquisition. It's a streamlined process for militarizing commercial products. When I say streamlined, that means 2 years, the program from start to finish. It has to be finished. It has to be developed, tested, and delivered within 24 months. And that's no matter what system that is. So in order to be successful for a commercial company to have a product successfully complete that process within the time frame, this tutorial is going to show you how to do that. Okay, so that's the commercial part. There's also going to be a hypothetical Monolith-Sat. I have a little prop here. This is a CubeSat. So you can take one CubeSat and you can design them to operate as a system. And so you can construct a monolith by combining CubeSats as a system, and this has multiple purposes, right? Now you have built-in redundancy, low cost, so because actually one of these is 10 by 10 centimeters. So you can pass these around, and you can throw them around if you want to, because they can't hurt anybody. So you get a physical feel of what I'm talking about and the benefits of it. And so during this course, we're going to have a hypothetical monolith type system that I'm going to discuss. Okay, so the approach of this tutorial is, it's to guide you through the maze, and we're going to take shortcuts because I'm going to show you checklists, and checklists are the way to get things done based upon the experience of others. And so this is going to be filled with checklists. Okay, for the tutorial itself, okay, for the next 4 charts, I'm going to show you exactly everything that's going to be in this tutorial and when it's going to happen. And if I get off schedule, you can remind me, okay, that you're off schedule. In the first half, from 9 to 12, this is part A. Okay, you read yourself, okay, but I already talked about the UCA. There's a UCA pathway, and there's DoD documents that actually talk about the framework of that. I'll discuss those. SR&QA means reliability. You're going to see that several times: reliability, safety, reliability, and quality assurance. That acronym, SR&QA, safety, reliability, quality assurance, is throughout this presentation. And I'm going to talk about the attributes of SR&QA for military spacecraft, attributes of SR&QA for commercial spacecraft, the differences between military and commercial SR&QA attributes, the Department of Air Force policy, which defines resilience, which is not a commercial attribute. Okay, resilience is not a commercial attribute. Okay, this ANSI AIAA, American Institute of Aeronautics, Astronautics, which I'm the chair of this S-102 standard working group. In those standards, the definition of durability is defined. Okay, now durability is the closest thing that, as far as the product design, that you're going to get to resilience. And there's going to be an explanation of what the differences are. There's commercial to military, SR&QA attribute transferability. You have to go from, if you're taking a commercial spacecraft, you're going to militarize it. There's a process, okay? There's the capability-based SR&QA best practices, and that's what you're going to use in order to be able to meet this 24-month from birth to delivery schedule for UCA, which is the fast track for at least DoD in order to militarize commercial products.
What does UCA stand for?
Urgent Capability Acquisition. I'm going to talk about the overview of commercial products, SR&QA attribute requirements, verification methods. That's very important because the way you verify something during commercial is going to determine how much trouble you're going to have when you militarize it. All right, and then I'm going to talk about the difference between the capability best process and an ad hoc process. Okay, so that's the first quarter of this course. The second quarter is going to be understanding operational dependability. It's an attribute that is critical to a customer. It's a customer's attribute, okay? It's going to be, the next topic is going to be hazards that can degrade spacecraft dependability, a Venn diagram of how processes, safety integrates with reliability and quality. There's a Venn diagram, overview of what capability-based mission assurance program is. Mission assurance, it's an overarching program for these other programs for safety, reliability, and quality assurance. Mission assurance is an overarching program. I'm going to talk about functional hazard analysis, which is a safety, mostly, system safety tool, and also about the FMECA stands for failure mode effects and criticality analysis. I'm going to talk about that because it supports it. Sneak circuit analysis, which some of you probably haven't heard of, which is very old and very important, and I'm going to explain why. Then there's something called failure reporting analysis and corrective action system, which is commonly known as FRACIS to a lot of people, which is underutilized and very important. The next topic is understanding the states and modes, and then I'll answer questions for 10 minutes. Then there'll be a lunch break. So that's the first half. And then this afternoon, talk about understanding what faults faults, the difference between faults and failures in engineering, you think, okay, well, that's minor. But the difference between a fault and a failure is important to safety, because sometimes when you have a fault, it's reportable and it's not being reported. That's an issue that, whether you're experienced or not, there's people who don't do safety all the time. When certain safety incidents happen and they're not reported, they end up costing the customer money, and that's going on a lot. So at least I'm gonna make you aware of it. Okay, so I'm gonna harp on that a little bit. Define the difference between incidents, mishaps, safety hazards in terms of engineering. So you understand the differences, what's reportable and what's not. Mishaps and failure severity definitions, I'm going to talk about that. And then we're going to get into the spacecraft. Actually, other thing, talk about the categorization of what a small spacecraft is. That's minor, but it's information. Then I'm going to talk about the case study of a 60 unit, which would be 60 of those CubeSats combined into one monolith. We'll use that as a hypothetical example of a program. And then there's the role of space safety program, what role space safety program plays in that monolith UCA program, the monolith satellite flight software safety, which someone asked about software safety. We're going to go through that. We also are going to talk about what that monolith satellite orbital debris assessment should cover. The last section, or last quarter of this tutorial, that monolith satellite, the safety critical identification and management, which is going to cover the artifacts. And then there's the human reliability aspect, which traditionally is covered by system safety in another aspect, but I'm going to cover the human reliability background and process that the experts use, which at least you should be aware of. Okay, and then I'm going to cover a section that one of my co-authors had added to this, and that's the hypothetical CubeSat launch safety process. That's the government's, that's U.S. Space Force process for launching CubeSats at Vandenberg. Then I'm going to get into the details about what hazardous items in areas should be assessed. Okay, so that's pretty much what's going to be covered during this morning and this afternoon. The terms that you're going to see, I'm going to show them now. ADR, which is anomaly detection and response, the functional hazard analysis, it's FHA, FAMICA, FRACIS. I already talked those terms already. The human reliability HRA. Life cycle systems engineering is a standard 5-phase life cycle process. Okay, that's universal. Life cycle for every product has 5 phases, and that's the life cycle. And then there's the reliability, RMAT, reliability, maintainability, availability. I already talked about SR&QA, but there's an embedded term called RMAT, which is, reliability, maintainability, testability. So it's still SR&QA. Then SUS is small unmanned spacecraft. You're going to see all these acronyms throughout this tutorial. Let's get started for the UCA process, which is the Urgent Capability Acquisition. That's the DoD process. So these two documents define the DoD mandated criteria for something, a commercial product being entered into the basically militarizing a commercial product within 2 years. Okay, there's no variability. All right, you can't get in and think, oh well, the customer is going to give me 3 years, 4 years. No, if you can't fit it, if you can't complete the process in 24 months, it's a failure. Okay, it has to be shut down. All right. You can look up these documents. I'm not gonna go into the details, explaining what's in there. What I told you was exactly, okay, it's mandated, it's 24 months. And these documents, these DoD documents stipulate that. Okay, so let's look at a military spacecraft. And when it's delivered, what's important to the customer are that this spacecraft have these attributes, and these attributes meet your customer, at least military requirements for performance, safety, and reliability, all right? So the attributes are, every spacecraft, it has to be safe, it has to be reliable, it has to be dependable. Okay, now, Now, dependable means, which is different than available, okay? Okay, dependable means it remains up and operating for a high percentage of the time it's supposed to be operating. And that number is in the high 90s. Because depending upon what its mission is, you can't say, oh, it's down, sir, that we can't detect such and such during a military operation. Nope. It has to be capable of being operable during a high percentage of time it's required to be operating. All right. Dependable aligns with dependability, and that's what this is the main theme of the tutorials, because on the customer side, dependability is one of their highest ranking requirements. Okay, it needs to be reproducible. Okay, the other attribute, like those CubeSats, okay, even though they're cookie cutter, right, they all fit in the same physical frame. If you can't replicate the quality of every single one, then your system won't meet your requirements. So that's what reproducibility means. You have to have a process in place where every product meets the same level of quality. It has to be qualified, which means it has to pass, its tests for being deliverable. So you have to test it and qualify it. And then we have this other attribute, military. Now this is military for military spacecraft, right? This other attribute is resilient. It has to be resilient. Now for commercial spacecraft, they have the same attributes, except there's a terminology difference between what's qualified and what's certified. Is basically the same thing. It's just in the military arena, the requirements have to be qualified, but in commercial, the terminology is usually certified. But pretty much they're the same. But there is no resilience, equivalent to resilience in the commercial, but there is a attribute called durable. It has to be durable.
Can I say something?
Yes.
As far as reproducibility, we've been working on the GPS satellite. So we started from SVO1, and now we're on SVO9. We only have one more. We have two to launch this year, and one's going to be 9 and one's going to be 10. So the great thing about that is that the reproducibility, now that our contractor, who's Lockheed Martin, that builds that satellite, I mean, the processes are so smooth now because we've been reproducing it, right? So from the first vehicle, which we launched several years ago, now, I mean, even as a system safety engineer, I urge you guys all to go to your contractors if you work for the government and just see their processes. And so even going to their high bay, the process is so much smoother now, because they've made so much more advances in the reproducibility. So that's a very important thing. And we as system safety engineers also, we need to make sure we have those lean processes. So we've developed, in my organization, we've developed a lot of lean process to help with the reproducibility. Not only does a contractor have it, but we, with all of our documentation, to accept their product. That's all.
Okay, thanks. Okay, so the difference between military and commercial attributes, since the definition qualified, the qualified military spacecraft is equivalent to a certified, for commercial spacecraft. The only difference between the attributes is resilience and durability. That's really the only difference. All right, as far as attributes. And as I said before, some of the features of resilience are identical to the durability. Just some of them, but not all. All right. So here is what resilience is defined as. Resilience is defined as the ability of an architecture to support functions necessary for mission success with higher probability, shorter periods of reduced capability, and across a wider range of scenarios, conditions, and threats. Remember that term, right? Despite hostile action or adverse conditions. Resilience is one of the 3 key components of space mission assurance and is comprised of protection, proliferation, deception, diversification, distribution, and disaggregation. All right. So as you can see, there are terms in there that you don't develop a commercial product to. Right? If someone intends on damaging your product, you don't cover it, right? I mean, you can't design against every threat to a commercial product. So that's why resilience is not equivalent. You don't have anything in a commercial industry that's equivalent to resilience, which is one of the attributes that military products have. An example, okay, but however, one type of military spacecraft adverse condition, it's an adverse condition, right, is a human-induced high-intensity EMI pulse. So if somebody fires a EMI weapon at your deployed spacecraft, to destroy its ability to communicate or cause damage to it, that's an intended action that could disable your spacecraft. But it's EMI. So in durability, in the definition of durability, there's nothing in there, and this is actually standardized in one of the S-102 standards, AIAA S-102 standards, okay? This definition of durability is in there, okay? There's nothing in there that says that design will address anything that's intended to cause damage, intentional damage. So it's not designed to address that. However, EMI can be naturally created in space by the sun, right? You have sun's flares, and sometimes the EMI that is created by it is similar to the EMI that can be intentionally created by people. So if you design a spacecraft to endure sun flares, then you have created a spacecraft that can address at least one aspect of something that can be man-made, right? So EMI can be naturally created or created by man-made weapons. So it's important to keep that in mind if you're developing a spacecraft that you intend to sell or you hope to be able to sell to the military, that you design this capability into the spacecraft, before you try selling it, as opposed to after, because if you don't do that, you probably won't be able to meet the criteria of having your spacecraft complete its life cycle, or at least its producibility and deliverability in 24 months, and that's why you have to keep in mind that you can't fully address resilience, but you can address part of it by designing a spacecraft to be durable against naturally hazards in the space environment. Simple point, but it's important. So given that, then there's this transferability theorem, which is simple, is that if you design a spacecraft to cover all the attributes, the 6 attributes that were identified for a commercial spacecraft, then the artifacts that verify that you meet those requirements can be applied for the qualification of the military spacecraft. And that will increase your probability of being able to meet the criteria of 24 months because you've covered 5 of the 6 attributes fully, and then with the resilience attribute, partially cover it requirement and spend that 24 months addressing that portion of resilience attribute that's not covered under when you design a spacecraft to be durable.
So I have a question. Would partially covering the resilience, would that fly? You know what I mean? Would that be acceptable? If you partially...
No, it won't be acceptable. What I'm saying is, but that's the only thing you would have to do, right? I mean, so you filled the bucket 90%, and then you just have that 10%, as opposed to only filling the bucket halfway. See, you only got 24 months, right?
Yes.
Right. So I'm saying this increases your chances of being able to meet the requirement. Now, you're the customer. You're not going to accept something saying, okay, well, I'm sorry, but this will not meet your military requirements. You're not going to do that. Okay, but you don't want to start a program where the chances of because there's so many other things. They might be product safety, they may not have covered. Reliability, they may not have covered, right? You don't want to start a 24-month program when basically you got to redesign the whole thing. That's wasting government money. Now I'm going to talk about what capability-based safety, reliability, and quality assurance best practices are, and what they do is they're the key to being able to have a successful UCA process. This 24-month DoD process. because these best practices, the capability-based practices, will address all of those other attributes, address all those attributes to the greatest extent possible. And this become clear as we progress, further down in this tutorial. So here's the difference between capability-based safety, reliability, and quality assurance processes and what really is ad hoc. Ad hoc is when for instance, like a safety program, is started and it's implemented based upon what a contractor either can afford to do or thinks that the customer will accept. It's not really tailored for the requirements. It's tailored based upon what, like I said before, what the contractor can do or what they think the customer accepts, not the requirements. All right. So the commercial requirements verification methods, which are the methods that a commercial contractor is going to use to verify that the safety requirements are met, the reliability requirements are met, dependability requirements are met, the producibility requirements are met, certification requirements are met, and the durability requirements are met. At least an overview of what those verification requirements addressing are in the right-hand column.
So what is FD and FI under reliability? What's the FD and FI? What does that stand for?
The bit built in. Okay.
I know what bit is.
Okay.
The FD and FI.
FD is fault detection.
Fault detect, right? And FI.
Fault isolation. Fault detection and fault isolation is critical for safety when you're talking about being able to detect things that, if not addressed, will lead to damage.
And also to identify controls for that.
You're right. Anything that if no action is taken and it will lead to damage, it's in safety bucket, no matter what anybody tells you. Okay, so you don't have to jump into the safety wagon and say, okay, well, safety only concerns is only an issue when something is damaged. No, okay, safety is the owner, if not detecting something to prevent the damage fails. That is safety's responsibility. So there are 7 space mishap risk areas. Okay, so one of them is the spacecraft internal induced mishap or failure. And I'll tell you the difference between, what's classified as a mishap and a failure, okay? But for now, I'll tell you, okay, the mishaps are addressed by safety engineering. The failures are addressed by reliability engineering. And so there's the spacecraft internal induced, like I said, mishaps or failures. The second is the ground control induced spacecraft mishaps or failures. The third one is the spacecraft environment induced mishaps or failures. The fourth, the spacecraft end of life disposal mishaps or failures. The fifth is the spacecraft orbital debris generation risk. The sixth is the spacecraft collision avoidance mishap or failure. And the seventh is the spacecraft deployment or pre-orbit mishap or failure. So, and this is all just spacecraft, okay? This is not, this particular is just a spacecraft, okay? Launch vehicle is a contributor in the seventh one, where for deployment, but the launch vehicle has its own fault tree, okay? But as far as the spacecraft, the seventh one is the safety and reliability of the launch vehicle is part of that.
Yes, the 7 mishap categories, the areas you identified, are those analyzed independently from a hazard perspective, or do they ever come together in some type of integrated analysis?
Yeah, they come together. A hazard analysis addresses all of these, all 7 at the same time, if that's what you're asking.
Okay, so for example, a fault tree analysis, that's when you pull in anything that would lead to that mishap that might come from one of the independent. Okay, thank you so much.
Right.
If I can add to that too, I know when you're doing your fault, when you're doing your hazard analysis, that you'll have some on-orbit hazards that you identify, and that covers some of those areas up on the fault tree.
Right. Oh, by the way, the fault tree, okay, this is put here just to give you one example of how this is addressed. There's different ways. The fault tree is not the only way to do this. Everyone knows that, right? There's more than one. Fault tree is not the only way to do this.
Yeah. If I can add something else too regarding the spacecraft orbital debris generation, there's like, I know we have with the Space Force, we have a separate documentation where we look at orbital debris generation and we, the space debris assessment report where we go into quite a bit of detail to handle number 5 as well.
Okay, there's a standard. This AIAA S-102.2.14 is a commercial standard, and the title of it is Functional Hazard Analysis. So I'm only bringing this up to show you that in addition to the military standard, which is MIL Standard 882E, which has minimum mandatory requirements. Okay, I make sure everybody understand that there are minimum mandatory requirements for U.S. right DoD system safety. So you can't, a contractor can't think there's certain things we can do, and the customer would have to settle for that. No, because every DoD product has to comply with the minimum mandatory requirements. And if you want to know what those are, get the standard, and it'll tell you in section 4 exactly what those are, okay? So this commercial follows the same line of thinking, same process, okay? There are minimum mandatory requirements. So these are pretty much the same risks that are in that fault tree. And all this says is that at a minimum, a small unmanned spacecraft supplier has to address these risks. I mean, it just makes sense, right? Okay, if you have a risk, you have to address them all. That's all. That's all this is saying. And that's what a minimum for this commercial standard, that's what the minimum mandatory requirements are. And this chart goes into a little more details about what each of those risk areas are. So for the spacecraft internal induced mishap or failure risk, the spacecraft supplier has to inspect the spacecraft functional hazard analysis, the anomaly detection and response analysis, the product FMECA, which is failure modes effects criticality analysis, the sneak circuit analysis, and the FRACA stands for failure reporting and corrective action analysis. Okay, the supplier has to inspect those records for verifiable evidence that all fault tolerant safety design requirements are met. So this puts the onus on the supplier to evaluate the analysis products that they produce to make sure that those products address safety, which it should be done, right? Before a supplier delivers a product, they should naturally make sure that the artifacts for delivering that product to the customer have sufficient evidence to verify safety has been met.
So you articulate there that the supplier or the contractor, lead contractor is supposed to review all of those safety data products, right?
Right.
Your safety data products.
Right.
To ensure that they're compliant with that AIAA mandate, right? Is the expectation that there would be a performance or a generic requirement in the contract spec that would then be the mechanism by which the supplier would show compliance to that particular requirement? Because otherwise, what's to preclude a contractor from just saying, yeah, we looked through all of these things and we think we're compliant for our FHA, our ADR, our sneak circuit, our practice stuff. I'm trying to see how you can show compliance to that particular requirement aside from a contractor just saying, we adhere to our internal processes for safety documentation, and we think we're good.
Yeah, right, which makes sense. Okay, and if it was just based upon a verbal claim, then and there was no specific artifacts documentation required, you're right. Okay, but if there is a standard that actually documents what data should be included in the results, then the contractor has to use that. They can't be just verbal claims.
So for example, there's a very tailorable version of a functional hazard analysis that you can use from a military perspective, but it may or may not be depending on who the contractor is, it may not satisfy every single identification of hardware, monitor, software, interface detection method, et cetera, et cetera.
Yes, I understand, right?
So what, I guess in other words, what takes precedence here? Does the satisfaction of the contractor did take precedence over this particular mandation, or is it, how are we supposed to satisfy that? If the functional hazard analysis template that we're working on doesn't satisfy those.
Okay, so, and I'm familiar with the situation, right? Because the contractor would for instance, would say, okay, so we have an equivalent, right? Equivalence, right? Okay, the contractor says, okay, we have an equivalence and tells the government that, and the government say, okay, well, if you say it's equivalent, then obviously it's equivalent, all right? But this says, if you notice, it says AIAA S-102 2.4 mandates. Okay, so if the government had put this in a statement of work, right, then the contractor has to meet these requirements, not their requirements.
Yes. I was going to say the same thing because I was thinking about the request for proposal that you would get. And your request for proposal, you'll have the information in there that this is what you need to design it to. This is what your safety program looks like.
By and large, it'll say something like they'll say an AAA2 acronym, right, or something to that equivalent, and it won't call out the AIAA standard necessarily. But in the event that it does, you would need to tailor the DID or whatever documentation that you're using in order to ensure that you're satisfied.
That's right.
Exactly.
That's right. So,
And you do have the ability to tailor, because in contracts, they have that section in the contracts that have the tailored documentation.
Contractors find that acceptable, right?
Yes.
It's oftentimes something that happens.
Yes.
Procedural.
okay, so here's more mandated, minimum, mandatory requirements that are in that AA document, okay? And if only in the statement of work or PWS, which are, a performance work statement, PWS, performance work statement, okay? If it only has references this standard, then the contractor would have to provide, data in order to meet those requirements. If there's a statement in here, like you just referenced, that says it's terrible, or the contractor can tailor it, then you're not stuck with minimum mandatory because you can change anything you want to. So it's really up to the customer, right? It's really up to the customer whether or not they want a product that basically is ready to go at the end of its development cycle, okay? Or if other things are more important, such as budget, if they want to meet budget or such, okay?
It's kind of like right now we're looking at something that's where this one particular contractor wants to do. They want to do it from a commercial standpoint, and we're trying to figure out, okay, what products do you have in place that are equivalent to something that we're used to seeing to guarantee that you have a safety program. Because I came to learn just like you guys did too, and this particular one is helping me to understand, okay, so there is something that commercially you can use that looks like what we as the customer wants to see that meets our safety requirements. So that's the thing that we're going to look at. Hey, how do we know that the product is safe from our standpoint? And so having these minimum mandatory, I guarantee is not going to be tailored too much, because there's still things that we're looking to have met that's comparable to what we know and that looks at a safe product.
I got a question. With a single point failure mode, is that handled differently when it comes to software involving like a safety critical function? Is it for like single point failures?
Yeah, just
Is there like more?
more, okay. Okay, you asked about single point failures. Okay,
Do you handle that differently when it comes to software with higher criticality?
are there specific requirements? Okay, because there's a lot involved in that question you just said. Okay, are you asking, are there similar requirements that apply to software, or are you asking?
With higher criticality, catastrophic or critical
Safety critical.
severity. For example, do you still look for like just single point failure, or you consider like what could also, happen?
Okay, okay. The first thing is, here we go. Okay, look, the first thing is a single point failure doesn't necessarily have to do anything with safety. Okay, that's the first thing. Okay, because with that said, okay, so anything that a precursor to a mishap is the safety bucket.
Software.
Okay, I mean anything that you can think of. Okay, but the key is to have a definition for mishap that is distinct between what a reliability engineer would think of as a failure. That's the murky area that everybody's fallen into. All right. Some failures are misinterpreted as mishap risks, but some failures that should be mishap risks are being ignored.
I think what he's talking about too is with software, specifically software.
Well, yeah. But remember what I said. I said a precursor.
Yeah.
Okay, which means there's this concept that software never fails. Okay, it's designed. I'm serious. Okay, some people think that. Okay, they say software doesn't fail. It does what you designed it to do. Okay, and if your design was bad, the software is bad. But you can't fail software. It's just you design it, right? But then when you test it, it doesn't meet its requirement, right? So they said, well, okay, so that's a design issue, and you can just redesign it. But it never really failed. You just fixed it. You just found that okay. But if that software didn't operate, and I said this, before, if it didn't operate such that it didn't prevent a mishap, that's safety. If the function of that software had anything to do, it's required to prevent a mishap, which is damage or injuries. Okay, then that's safety. So if a single piece of software or one code in software could if it fails to do a function to prevent damage or injury, then that was supposed to be in a hazard report. It's convoluted. I don't know how it didn't, and it makes no difference how many steps you have to figure that out. Okay, even if it's even if three things or four things have to happen in a row, but they could happen, which would make it a fourth order event, right? If four things have to happen, okay, the safety engineer is supposed to identify that. Do they have the capability to do that? Do you have the capabilities? People are here. Do you have the capability? Okay, go ahead.
Well, I was just going to say, it seems to me like what you're asking about is the equivalency between a FLICA, where you identify your single point failures from a hardware perspective, and the software. Like, is there equivalency there? And from my experience, the functional hazard analysis that a system safety team perform, or software safety team identifies the control authority that the software will exhibit over safety critical systems.
Right.
And if it's autonomous, meaning that it's like the equivalency of a single point of failure, you would identify it and you would apply a higher squeaky level, or how much rigor you have to put into the system.
Right.
So from my perspective, it seems like the equivalency between a single point failure analysis from MEGA, but applied to software, would be your FHA, your
Yeah.
functional hazard analysis.
Yeah.
where you would
I agree with that. That's what I was thinking about, your functional hazard analysis, because if you have a software intensive program and you need to do your safety analysis, you'll be doing a functional hazard analysis to look at those functions And that will be what handles your software.
Except I want to bring one point up. An FMECA is not limited to inductive, okay? So you can also do a functional FMECA. It can be
Yeah.
deductive, okay? So I just want to put that out because some people think, well, it's supposed to identify one. No, and that was never the case. Okay, so these next few charts actually just break down what risks are involved in those 7 areas. The second area was the ground control function. Okay, ground control is where your human errors can occur that are going to impact the operation of the spacecraft. So, as you can see in one of those bullets, the contractor is required to inspect the ground control operations handbook, the OOH, and operator error assessment report. So, anyway, your contractors.
I've never heard of an operator error assessment report, but that doesn't mean anything, but that's a new one.
Okay.
You learn
Well-
something new every day.
Okay, well, at one point, years ago, okay, this was a standard way of defining how the ground controls operations were. Okay, maybe they've changed the terminology, but you have to have an equivalent. So there's an operations manual. Okay, just like when you get an appliance, right? Okay, you get an appliance. There's the user manual. Okay, every time you get something, you buy something, they give you a user manual. Okay, same thing. So, but for military systems, they have their own operators, they have their own ground stations and everything. So that's all internal, government internal. Okay, but if you're a commercial company and you're offering orbital services, you have to have something in place in order to define how those orbital services are provided. Now the closer that you are with your requirements for safety to those orbital services, the better off you are if you would like the government to make you an offer to buy either your services or your product. So you need to pay attention to this, okay? It's not just the hardware, okay? You have to have everything. If you're a commercial company and you want the government to be able to get you on a fast track for acquisition of your product, you have to cover it just like a commercial company would with an automobile, a washing machine, or anything else. You have to have a user manual and operations that the government can review and address all the safety aspects that an operator might contribute to the product. Space environment risk, we already talked about with solar flares. They create EMI that can interfere with operation of military spacecraft, okay, and commercial spacecraft. Is just that in some cases the EMI interference can be man-made, which is the aspect of resilience, but the natural sun flares can cause disruptions. So the survivability of the spacecraft should be designed in order to address that. And all of this predictable. It's predictable, okay? There are studies available that can predict how often during any period of time of a mission that there will be solar storms strong enough to disrupt your satellite communications. And you need to design against that. Otherwise, your dependability, the percentage of time that you're operable will not meet either the service requirements, either your own requirements or your customers. Because the dependability, the percent of time your system is up is really the reason that people differentiates between a company that you don't want to deal with because they're not, they can't provide you with high availability, dependability, and a company that can provide you with a high reliability, availability, dependability. Just like you would a car. If your car kept breaking down all the time, you wouldn't go back and buy it, right? The same kind of car, you would look for a company that sells cars that don't hardly ever break. And this is the same thing. End of life disposal risk is important because it's not a risk against at least the operational risk, right? Because once a space vehicle reaches an end of life, or a system, a constellation reaches its end of life, it stops making money for the operator, or whatever. It stops, doesn't meet its There's no mission to meet anymore. But then it becomes a risk to other assets, operational assets, and so it becomes a damage risk, to other assets in space, and so that needs to be addressed.
If I may say something with that, as far as your safing procedures, so you want to make sure you minimize the amount of fuel that's on board, your batteries are down, and all of the other things that go boom while it's in space. So that's why it's so important to have adequate safing procedures so that you're not like throwing a bomb out in space, that everything is as minimal as it possibly can be.
Right. So I'm pretty sure it makes sense to everyone, right? Why disposal risk is important. What's still sort of being developed, or maybe it's finalized, and I'm not familiar with the solution, is how is this to be enforced? Okay, right? Because all space systems that reach their end of life aren't U.S. space systems. Some of the countries send things up there, they become risk to everything else up there. So I'm just wondering, and this is just something I'm wondering, how is the UN addressing this? I don't know. Should the UN be addressing this? Does anyone know whether or not there is some international organization that can address the fact of multiple nations sending spacecraft that basically becomes junk and becomes a risk to other spacecraft?
I can say that we started baking in like some of the small sat programs that I've worked, the requirement with respect to end of life disposal and ensuring that you have minimal amounts of fuel, et cetera, in order to safely dispose of the mission itself. But those aren't regulated by any overarching international body. Those are typically on a contract basis, because a lot of the safety guidance books don't even have updates on that.
Okay. Anybody else have any information to provide? All right. Well, because in addition to the AIAA, which is a national, U.S. national standards organization, I also participate in ISO. Okay, and S14, TC20, Technical Committee 20, Standards Committee 14, all space systems, international. Okay, they have a separate working group writing debris minimization standards. Okay.
Is that handled in there? Do they talk about?
Oh yeah, they talk about all this.
Okay.
Okay. What's unclear to me is how that ends up in a statement of work for a commercial company. Those threads, I'm
We don't get any.
yeah, I haven't figured. Yeah, I don't understand how those threads. I mean, you have people from 10 different countries working on these standards. They're published already. Anyway, so I just want to bring it to your attention. Okay, this is what needs to be done. There's standards out there to do it. Those standards to be done on statement of works. Okay, and once I understand how it's done, then the next group that I give this tutorial to, I have some useful information, because now this is just something that needs to be done. I have no idea how it's been enforced. That's all, internationally. Okay.
We do know from the government standpoint that we have those requirements in place to ensure.
Yeah. I know you do
Yeah.
for U.S.
Just
government.
saying, yeah.
Okay. Yeah.
That's all
But-
we really know right now.
Yeah. Right.
going
But
to what you said.
also
Yeah.
commercial, right? Commercial innovative spacecraft the government wants to use. That stuff is all up there. Okay. Well, how has it been policed? That's all. Which there needs to be an explanation so that people like me can communicate to everyone to actually tell them, because all I have is just standards. How it's been enforced, I have no idea.
This is what it should be. How is it enforced? That's a question.
Right. Yeah, well, the way it should be. On-orbit collision is a risk. So now for that, there are services in place, both government and commercial, to address that. Structural integrity risk, that is something that is pretty much standard. And then there's spacecraft and failure risk minimization level of rigor, okay? Level of rigor, for those of you who are familiar with DoD products and Mill Standard 882, that is how software is being addressed. Okay, it's all level of rigor. Okay, that's not really a risk assessment. Okay, it's all level of rigor, right? So, but that same concept, level of rigor, okay, can be applied for system safety assessments. You can actually, as a customer or even as a contractor, okay, you can establish a certain level of rigor that matches the type of product that you have. So, for those of you who are familiar with level of rigor, it's not only applicable for software, but it's also applicable for everything else. All right, just keep that in mind if you want to put something in your statement of work to verify that the contractor actually did an effort. You can not only do it for software, you can do it for the rest of it, hardware too. To put where we are in perspective, I looked ahead to see exactly when the scheduled, what chart was supposed to have been covered by the first break, all right? And actually, we aren't doing too bad. The next chart is S-102.0.1 is the top tier chart. It's the mission assurance level. It's the mission assurance level standard for capability-based safety, reliability, and quality. So the one after that was going to be saying that one of the requirements is that the supplier is supposed to provide external access to their hazard reports, okay? Which is novel, right? So for a commercial company, that may be something that they are willing to do, and sometimes that they're not willing to do because in some cases, the products may not be safe. So that could be an indication of a company that could be the differentiation between a company you want to deal with and a company that you may not want to deal with. Is if you can find a company, commercial company, that's willing to comply with this requirement and allow their hazard reports to be available in the public domain, then you know that they have nothing to hide.
I have a question on that last slide.
Go ahead.
Should get your mic.
For clarification, I see safety critical functions here and safety related functions. Are you taking those out of the 882 definition, and do you look at critical safety functions?
You know, I'm glad you brought that up because actually that's addressed separately. I have a whole set of charts for that. Okay, I can explain now. That way I don't.
We can wait for them.
Yeah. But yeah, and as a matter of fact, I have a graphical diagram. Okay, just in case. Here we go. So I'll save time in the future. Okay. Just in case some of you may not even be familiar with the difference between safety critical item and a critical safety item. The definitions that I am familiar with, okay, are that in the domain, the set of safety critical items is a subdomain of critical safety items. The differentiation is safety critical could cover, severities from catastrophic to serious to moderate. That's safety critical. All right. Critical safety are catastrophic and critical.
Which one is that one? You just said
Critical safety.
critical safety.
Okay. Now, who doesn't agree with that? I'm pretty sure there you go. You don't agree.
That's because I'm doing a paper on it.
You're doing a paper.
So,
Go ahead.
public law defines critical safety items, and there's two different public laws, one from 106, I can't remember the exact numbers. I have them listed in my
Go ahead.
presentation. Critical safety items are single point failures that will result in the loss of an aircraft, and the other law says, or a boat. So it's a single point failure that can result in loss of the system. So all safety critical items, all critical safety items are safety critical.
Okay, we agree with that.
But the difference is between
Your definition is, the one you gave
the
is,
critical safety item is single point failure to loss of the aircraft or boat, or in this case, spacecraft.
okay. I'm hearing you. Okay.
Yeah.
Okay, here we go with
And
history.
in different groups, it creates a lot of discussion. That's,
Well, yes, and actually, okay. So I actually, and I believe I have the source that you just named, and I went through it. Okay, and I distilled it down to something that actually anyway. But I went through that source. Okay. So but that's not what's put in the standard. In that standard, yeah, the definition is what I just gave you.
great.
Okay.
I need to look that standard up. Thank you.
Okay. All right.
Appreciate
Okay.
it.
Okay. Sorry for the side discussion. When we get to this part, actually, I have a diagram to show, but it's very, very simple. Okay, I already said that the prospective customers of commercial spacecraft, actually the customers, okay, should actually request access to hazard reports before you buy it. And if the supplier says he won't refuse it, I would find a supplier. I would find a supplier who's willing to do it. Okay, make that differentiation. See, that's why I'm trying to. It would be nice if there were more commercial companies involved especially in the construction of spacecraft in this monolith type concept comprised of individual elements like CubeSats. CubeSats are just a standard way of a standard design. A monolith could actually be built from any number or size of any size. It doesn't have to be CubeSats, okay, but you can construct a monolith on the same concept. If the commercial industry would actually expand and increase, actually be bigger, then the competition, there would be an incentive to compete to the needs of the customer. Now that's not necessary. It's very small of commercial companies, and so the competition isn't being driven by competition, all right? So hopefully in the next few years, the number of suppliers in that domain will expand, and the competition will create the ability to do things like this for companies to actually provide their hazard reports available to their customers.
Is that part of like the preliminary hazard analysis? Is that part of that you're talking for them to provide the hazards to the customer?
Okay, so a preliminary hazard analysis is one type of hazard report. So whatever stage, like in the preliminary design, if you have a hazards on preliminary design, then you should provide those. Okay, if that's as far as your design has gone, if you as preliminary design, you should provide those.
But
Okay,
you have your preliminary hazard list, and then you'll have your preliminary hazard analysis.
Right.
So, okay,
right.
that's the only way I was thinking about how they can supply the potential customer with their hazards. It's like that's the only way I can think about it. But
Right.
okay,
Right.
all right.
When I say you, I mean your company and everybody's company, they have their own formats for a hazard report, right? So a hazard report is defined by certain fields, and then what's included in those headings are the data. So it's just a report, okay? When you talked about residual risk, okay, now you're talking about an analysis,
Yeah, you've already done it.
right?
Yeah, I guess I'm trying to understand.
Yeah, right. I'm just talking about the report. Okay. See, the report is okay. What the system or equipment is, what is the hazard, what should be mitigations, okay, and then there's a risk equivalent to risk items, which is the severity and the probabilities. Okay, residual risk is the risk that remains after the mitigations have been implemented. Right. All right.
What I'm thinking that you're saying is that I know you have it has up here, it says the prospective customer should review the supplier's hazard tracking system record.
That's right.
Or an equivalent hazard risk management data source prior to purchasing any of those. So is it
it's kind of like, for example, if you had a system safety program plan and your plan talks about, yeah, we have a tracking system, this is how we manage our risk. This is how we categorize our risks in accordance with whatever documentation. If it's not, they'll send 882, it's an equivalent to that. That's what I'm reading this to say, should be able to review the supplier's hazard tracking system. Do you have a tracking system in place?
Okay, okay, actually,
Is that what you're,
no, okay. Actually, it's simpler than that.
Okay.
It's more direct, okay? So, I don't have a piece of paper, but if whatever's information is on the documented report itself, just the report, okay? Not the plan.
oh, you're just talking
Not-
about
not-
what's in the column?
that's
of your
all.
Hazard report. How is your hazard report set up? What kind of?
Not even that. I'm just saying, okay,
Yeah.
if you have a documented system, just make that document available. You don't have to talk about how you develop it or anything else. Okay.
This is the information that we have.
Just the
on
information that
records.
was captured,
Yeah.
that's
okay.
relevant to.
I think that's a reasonable request, but like the implication from this slide is that that's not being conveyed.
That you said is not being what?
Conveyed to the customer. Is that not always the case, that the customer gets the document?
Well, if you're dealing with DoD, they get that automatically. I mean, 882 requires that, okay? But remember how this tutorial is saying, this tutorial is for commercial satellite developers. This tutorial is, okay? Great, the government is here to see, and it talks about what the commercial supplier of spacecraft should do, okay, in order to be ready if the government wishes to militarize that spacecraft, okay. But before that opportunity comes, that's right. Okay, so all right, so that was the first half. Okay, so now we're into the second half of the morning session. Now I'm going to talk about operational dependability. So I've already told everyone that operational dependability, it's a ratio, and it's a ratio of MTBCF, mean time between critical failure, okay, over mean time between critical failure plus mean time to restore function. So this number needs to be in the high 90s% to represent a system that is pretty much operating when it's required to be operated. All right, and no space system that I know of, but it could be, right? No space system operates 100% of the time for long periods of time. They typically don't operate for various reasons for hopefully short periods of time. So this provides a breakdown. This formula is actually broken down here, and is broken down to its major components. There's downtime for dependability for hardware, software, firmware, the environment, and operator. Those are 4 components. Those are the 4 areas that should be included in every operational dependability requirement and assessment. Every assessment should include these.
What function does the operational dependability fall under? As system safety, I've never done anything with operational dependability. Is it something that's done in reliability? Is it something that's done in maintainability? Where is the operational dependability used?
So if you're you're asking from the customer, so you know what, okay, for instance, safety is actually part of all 4 components. Safety is, okay, it's a part of it, okay? On the customer side, your support, your government support, okay, is supposed to be able to go in there, look at a contractor's durability dependability prediction, and make sure that these numbers that they're giving you of 0.9999, et cetera, right? These numbers, okay, are backed up by real data. Real data, because it's very easy to hide assumptions instead of data, and you get a number, and you find out that number is based on an assumption, not data.
So where is this extracted from in accordance with,
Okay.
this-
Okay. First thing, you want to start from the requirement? What drives the whole thing? Okay. The ORD. It used to be.
Yeah.
The
I know
ORD.
the ORD, yeah.
Right.
Yeah.
Okay.
Yeah.
But they don't.
Yeah.
Anyway,
We have heritage programs that have them. So,
that's right.
Yeah.
And I'm a heritage person.
Yeah, I know, we all heritage.
Okay. Yeah. That's where it flows from.
I was just trying to figure out if I wanted to go back and say, hey, where did we talk about dependability? Who do I go talk to? You know what I mean? I haven't seen it in safety. Do I go talk to a reliability person? Where in the contract do we talk about dependability? That's what I was just trying to get at.
Right. Okay.
Is the operational dependability per space vehicle or amortized over the entire constellation of satellites for that program?
Both.
Both. Okay.
Right. Because assuming, right, which may not be the case, okay, but assuming that all the spacecraft are identical, which may not be the case, right? Right? Okay, assuming that all the spacecraft are identical, then that constellation has a mission, and so the dependability has to address the mission, not the, and each individual one has a contribution. So yeah, you have to do both.
Here's one last question. Dependability for software, is that just, does that include stuff like defects, software defects or known bugs, or is that, how would you go about calculating the dependability of software?
Okay, that's a study in itself, but I'm gonna no, I'm just gonna try to make it as short as I can. All right, okay. Software is actually reliability wise, it's like hardware. Okay, for instance, if you used a handbook method to do reliability, the only usefulness of that, like 217 handbook 217, the only usefulness of that is to compare designs. Okay, that's the only useful, right? Because you can say, okay, this design is better than that, this, et cetera. Okay, but some people use that and say this is the reliability, which is ridiculous. Okay, right? Okay. Right. So now to get the point I was trying to make here is that the only real reliability calculations are based upon real data, field data, failure data, and test data. That's the only real reliability. Okay. All right. Software is the same way. Okay. You have to have a record of, okay, how, during what periods of time, how many times that type of software, that type of code, actually there were faults found. What's the frequency of that? Real data, right? So based upon the frequency and the type of software faults, you can come up with a ratio of like a fault rate for software, a real fault rate. All right.
It takes a lot of data, though, right? Long time of operation before you can get that type of statistically significant probability.
Well, why you say that? Because, you can run the same code on a multitask computer, maybe 1,000 copies at the same time, right?
But would people pay? Would government or customers pay for somebody to go out and do that?
But wait a minute. Wait a minute. Here we go. Okay, we have two situations here. Okay, remember, this is mainly for supplier, commercial company. The commercial company wouldn't. Okay, if a commercial company is building something and want to provide it as either run it themselves, their own service, or if they want to sell it to a company that wants to service it, they need to do this. Otherwise the buyer is what is it? You use at your own risk. So this is essential for marketing, be able to make it marketable, to have some kind of way to verify that your system, your software, your operating software, okay, for your system is reliable. And if you don't keep track of that stuff, then it's going to be, use at your own risk.
I know that we, like, for example, when we provide software builds to customers, doesn't have to be government, that the tracking of software defects, bugs, things like that, test failures, et cetera, as part of the verification and validation process, I think is pretty well maintained, that type of data. But in terms of setting up and running multiple instances of the software code and looking for faults and how often that happens, that seems more, I don't want to say invasive, just time consuming.
Yeah, it is. Okay, just like everything else, okay, is time and consuming. But then who is settled with the risk?
Yeah, I mean, if the person that's operating this.
That's right. That's right. That's right. Okay, and with a small market, that's acceptable practices, because when you have limited sources, you can say, that's too time consuming, But if somebody says, well, that's okay, but such and such down the street, he can give me what I need. I'll talk to you later, right? That attitude won't be maintained. I'm only telling you, this already. Yeah, you're in a great position now, but like I said, you get that market to grow, and then you're gonna, the attitude's gonna change. But it's not. There's no point in changing now, because it's not driven by the market. Okay, we talked about this extensively already, so I'm not sure how much I have to go through operational dependability anymore. Okay, but I do want to mention this. There is operational availability. Okay, and there's a distinction between dependability and availability. Dependability, I told you, is operational period. Something is supposed to be operating. Okay, so you want something high nines, because doing operational. Okay, availability is the probability of being ready. Okay, I just want to make sure everybody understands that it's the probability of being ready to be operated, which for a 24/7 system, this service in space, there is no operational availability, because you're always supposed to be operating. It's just when, Well, this chart talks about, I mentioned here the mathematical simulation models for assessing the following spacecraft attributes: the space hierarchical functional flow, the spacecraft operating modes and mission timeline, the functional to physical association of each item in a spacecraft to include a minimum electrical. Okay. This is a dissertation of exactly everything that has to be done in order to actually do an operational dependability analysis. It consists of multiple analyses. This is getting down to the workmanship level. But in order to do it, pretty much every engineering function that you would normally have to do in order to develop and test a space vehicle, you would need data from that in order to do a operational dependability analysis plus some. Most of the things that you normally do in order to deliver a product, you use that plus additional information to do this, to do an operational dependability, okay? If you wait and don't keep records, proper records of the artifacts of all these other analyses that you needed in order to certify your product, if you don't keep judicious records and you try to do an operational dependability analysis by itself, it's going to be extremely expensive because you're duplicating a lot of effort. So planning and having integrated processes and keeping track of your information is critical, okay? Otherwise, we'll do this later, you're talking about duplicating efforts that have already been done, and it's not going to be cost effective. Okay, so the uses of commercial spacecraft operational dependability analyses. Commercial spacecraft DO analysis procedures are useful for determining the scope, in other words, capability level of the mission assurance program required to perform an accurate operational dependability analysis. In other words, one based on complexity of the spacecraft design, its worst case mishap failure severity category, its operating environment, its mission usage, its ground control interfaces, its means of deployment. Basically all these were this is the 7 areas that I showed you in that fault tree. And when you have identified 7 basically, domains of your spacecraft that you have to cover, you need some way to integrate all that. You need stovepipe engineering doesn't work. So you need some way to integrate that, okay? Mission assurance is a process for doing that. There's something called mission assurance that overarches your safety program, your reliability program, your quality program. You think, in my company, we have different departments, different managers. That's great, okay? But if you don't integrate those products and those elements, you're going to end up, doing the same thing 2 and 3 times and not knowing it because none of those departments are talking to each other, okay? So you need an overarching mission assurance program that's integrating all that stuff first and all those, managerial things where you have different departments and all that kind of stuff. That's great, okay? But that's not the way to cost effectively integrate products. Okay, you have to have a process in place that does it. Not managerial organizations aren't going to effectively do it. This is about operational availability for 24/7 spacecraft. This is not even important. It's just making sure the system is available, to be used. But for a 27 space system, that's not important. So somewhere in here, it should be what replaced the ORD.
Yeah, I see the second column is the org, but
When you want to find where the dependability requirements are, you go to this replacement.
what are the replacements in the column under org and all of those documents down below? Is that what you're pointing me to, or what? I'm not sure we got a lot of stuff on there, so I don't know what you're really referring to that replaced the org.
This document, I pulled this out of, okay, only address up to 2018, okay? So this is it's 7 years, okay? But my understanding is that for the ORD,
Because it looks like you're talking about prior documentation.
prior documentation. But this is this is the only thing that, because when I looked up the ORD, okay, they had this, but somehow I got the impression that everything over here, that this whole thing was like everything over here. Some of these documents here, like this one here, we replace the ORD.
When I get back to that, I'll look it up.
Yeah. You look it up because
Because I'm still not clear.
because the people in your organization need to know what to go to, and this is as close as I could get to a link to what's. I was looking at this here, and I didn't have time to actually pull these documents up, especially this one here. I found this one interesting. Okay. Here is, we talked about it, right, in general terms, but the uses of military spacecraft operational dependability analyses, great, right? Golden Dome. Everyone's heard of the Golden Dome, right? You understand the concept, what the Golden Dome is. So I don't have to talk about
Oh,
it.
you can talk about it. I don't understand the concept. I've just heard of it.
Great. I actually like talking about the Golden Dome.
Okay, well, let's talk about it.
Okay. And okay, you can't say I'm revealing any secrets because I'm not, right? I'm not part of DoD, okay? This is all public domain information, okay? Okay. So, the concept of the Golden Dome, okay, first thing is the Golden Dome is not new. This whole, it's not new, okay? There are systems that implement part of the Golden Dome, okay? So I'll start with those first. When you have areas on Earth, hotspots, that are possibly threats for missile launches, continental ballistic launches, then you want those areas monitored 24/7 to make sure that you have enough time to send your anti-missile missiles to stop them before they're on
For impact.
right, okay? So you have to have 24/7 coverage of that, all right? So everybody understands that, okay? And we have those in place, right, okay. The problem is, what if somebody's firing missiles at you and they're not in those hotspots? What do you do? No solutions? Everyone's quiet. I don't know if you're afraid they say something, but but anyway, so the solution is you have to cover the entire Earth. That's what the dome is, okay? You have the same capabilities for that we currently have for isolated, for defined areas. You cover the whole Earth, all right? And that's actually that's practical because basically a nuclear sub or submarine has the capability of traveling almost you can be at any coast around the world, okay, any coast, right? And it depends on where they are. They could fire a missile or multiple missiles, and if they're intercontinental ballistic, it's how close they came to your coast, okay? Then you would have a hard current with the present systems, you're defenseless. So if you cover the whole Earth, you would need some way to detect launch, and some way to respond by being able to destroy before they reach their downward path to Earth, and so the Golden Dome is two parts, right? Detection and destruction, and all that's to be done from space. Okay, even the destruction of a missile is not to fire another missile to destroy it, but is to have the capability to destroy it from another offensive system in addition to the defense. So it's two parts. So dependability is critical. Simple, right? Simple concept. Question is cost. Concept simple, okay? Cost is another issue, all right? Huh?
And schedule, whether or not completely.
Oh, well, why is, yeah,
I mean, when they announced the Golden Dome a couple months ago, they said they wanted operational in 2 years, right?
yeah, they can have it operational in 2 years, okay? Yeah, sure, right? They can.
If the price is right.
Yeah,
It's all money.
yeah, that doesn't mean it's gonna work. Right?
Operational dependability.
That's right. That you can have anything at any time. That doesn't mean it's going to work. Okay, so it's up to the customer whether or not they're going to accept that risk. Okay, I'm only here telling them what the risk is. Okay, all right. So, okay. So did I answer your question?
You did.
Okay, all right. Now, like I said, it's not new. it's anyway.
It sounds like that the concept has been around for a while. It's just that now it's like, okay, let's really make it happen, kind of thing. Is that not true?
Yes, you're right. You're right. You're right. Now it's let's make it happen. Right. Yep. And being a taxpayer, I'm concerned that, I want to make sure that my contributions to this are properly used. Okay? So that's why I'm telling you, because I can't do it myself. I have to depend upon the government making sure that my tax dollars are being properly used. Okay, so I already explained all this, and this showed the 2 steps. You detect, and then you have the attack vehicles also there. But the main thing is, to make sure you have full coverage. Yeah, well, this talks about, okay, this chart talks about life cycle cost. Yeah, and the Golden Dome's life cycle cost is going to be, okay, yeah, it's going to be quite huge. Yeah, because, okay, see, one thing is, the life cycle is not just a life cycle of one vehicle. Like this. This thing might, a CubeSat in itself, even a monolith might have, who knows? Let's say it have 20 years, okay? But then after 20 years, it's got to be replenished. So, and if you don't replenish it when you need to replenish it, and then you create gaps. So you actually have to fold in your dependability with understanding the useful life of what's deployed, and you have to relaunch and redeploy before your what's up there, and so the cycle keeps going. So that's why availability. Do I talk about it here? Availability is important, because if you see, availability is, the ability to be ready to be operated when needed. And if something fails and you're not available to replenish it with a launch and deployment, then you create a risk. So that's how the two tie in. Okay, you have to understand when things fail, or when they end of life, useful life, and also your ability to replenish it when that, before that occurs, which is not always the case. Here's a list of hazards, an example list of hazards that can degrade operational dependability. I especially want to bring everyone's attention to the very first one, sneak conditions. For those of you who've been in industry for many years, are familiar with the term sneak circuit analysis, then I'm not telling you anything new, okay? For those who haven't been in industry for many years, you can finish your entire, you could have finished your entire college career, worked for years, and never heard the term sneak circuit analysis or sneak condition, okay? And I found that out is a fact. So what it is that in addition to systems that fail due to some physical condition, there are on occasion, or there have been on occasion, and still are, okay? Systems fail to function. There are on occasion systems that fail to function due to conditions that are not physical. In other words, there's no damage at all to any, there's no, even at the component level, okay? There's no damage to any components, okay? We're talking about things like mistiming, and there's others, okay? So things can happen that don't involve physical failures. System either doesn't operate or operates in a fashion that is not intended to operate, okay? And when that condition exists that impacts the ability to keep a system safe, then it falls into the safety bucket. If there's software that that doesn't involve any failures, hardware failures, that can cause the system, some mistiming, sequence issues, and prevent a safety critical or critical safety function to occur, that's in the safety bucket. If it's not so safety critical and it's not critical safety, then it's in the reliability bucket, because it impacts mission but not safety. So I just want to bring that to your attention, because later on I'm going to show you a severity definition table that aligns with the one in Mill Standard 882E, but it addresses things like this. Yeah, it isn't apparent that it can address something like that. Okay, so I just want to bring number one to your attention. You know, the others I think everyone else should be familiar with. Yeah, collision, structural faults, all this other stuff is something everyone should be familiar, but not so much with a SNCC condition. And there's a formal analysis for that. Like I said, SNCC circuit analysis.
Questions?
Yes.
Yeah, in the resilience slide at the very beginning, you talked about the military definition of surviving like attack, like this electromagnetic pulse. Where might that fit into like this place?
Okay, so actually, I can look at that. I can look at this. So first thing I will remind you, like I said, okay, that the focus of this tutorial is on commercial systems that are ready or should be ready to enter into the 24-month UCA phase. Commercial systems, okay? So when you asked about, okay, being attacked, that's intentional, which is not commercial. I just want to remind you of that, okay? Okay. However, I said there was an overlap, right? There was overlap between durability and resilience, and the overlap is the environmental, what naturally could occur as a threat, environmental threat, naturally, that also could be man-made, which is like, EMI, right? So EMI is the one overlap, okay? And that would be, unintended, number two.
So you're building resilience to this condition regardless of its source.
That's right. Right. Okay, overview of mission assurance program. Okay, now we're getting down to the details of what a supplier can do. Actually, they're supposed to do, right? Like I said before, actually several times, that the mission assurance program is the overarching program for these, for product safety assurance, reliability, maintainability, durability assurance and quality assurance, Process-wise, these three legs, okay, are supposed to be integrated process-wise, okay? And that's what the mission assurance does. Managerial-wise, you can do it any way you want to, but process-wise, they have to be integrated like this. And see, well, what does this chart say? In a capability-based mission assurance program, product safety, et cetera, are determined or identified, assessed, and verified in a manner that is consistent with the following. Okay, this chart is to actually make the reader aware that the capability-based, that word, capability-based, means that based upon the needs of the product, the processes that are applied to that are tailored for that. The needs of the product. It's not like, one size fits all. Some company says, okay, we do things this way, okay, regardless if it's the most dangerous product in the world, a very dangerous product, or a lot of threats, or if it's something simple that could cause only minor injuries, we still only apply this one process to it. No. Okay, the capability base is defining the level of rigor, effort is tailored to the severity of the product. Okay, there's a structured process for that. This is not new. This has actually been at times addressed in military, actually, I believe either 882B. I don't think it's with B or C. Okay, one of those actually has this. They actually have a breakdown of based on severity, what safety tasks. You don't do the same task for every product. It used to say, okay, well, for catastrophic program, the product, you do these safety tasks, and then if they're, only serious, you do these and this, okay, and it's stacked. It's stacked, okay. Unfortunately, that went away, and people forgot that. It's like lost human knowledge, right? But
I think now the only thing that's in most standard 882E is in the back, and it talks about the different types of acquisition programs.
Yeah.
And then what documentation that you should do for that.
Yeah.
Yeah, when I'm listening to you say, I'm like, when was that? So no, that would be nice.
Yeah, it is.
There were some things that were taken out of Mill Standard 882. Whoever decided that they wanted to take it out, they shouldn't have. And they probably weren't the ones that were doing the missions.
That's why we have commercial standards. You know, I cannot influence DoD. How, right? Maybe you can, okay? But I can influence, okay? So when something like what we're talking about that was useful is captured in a commercial standard and it's maintained there, okay? So if the customer wishes to utilize it, then it's there. Okay, so here's a graphic of the type of integration that should be implemented between the domains of reliability, product safety, and quality. So this Venn diagram shows, you know, which, and this is all, you know, this is just generalized, right? Which processes, you know, are exclusive, you know, for that type of that domain, like, and which ones overlap which other domains, and which ones are common to all three. This process should be defined in what's called the commercial companies or commercial suppliers command media. That's a common term, command media. Command media defines what a company is does, regardless of who their customers are. It's their
Standard mode of operation.
standard mode. You're right. That's the easier standard mode of operation, regardless of what their customers are.
Now I have a question. On some previous charts, you had mean time to restore function. You had it defined. One place it says mean time between. Go back to your bin.
Oh, go back to this.
Yeah, your bin. Yeah, right there it says mean time to restore function. So on previous charts, you had mean time to restore function, but then on that same chart, you had mean time to restore failure. Is that the same, synonymous? You have it defined to.
No. You show me where I have, because that's a typo.
It's a
Okay,
typo.
now if
Yeah.
if it actually says
Yeah,
mean time,
it does.
no. Okay, but let's check. You said I had
It
okay.
says mean time to restore failure. And then.
Well, no. Mean
on that
time to
same- On that same chart, you have mean time to restore function. So I was just curious, is that the same, as it's synonymous, or is that a typo? Like you said, maybe. You talked about that earlier, like in the
That
beginning.
was the mean time between critical failures and mean time to restore those failures.
He said, yeah, but see, it was the same acronym though. That's why I was asking if it's the same. You know, if it's interchangeable, or these are two different acronyms, or.
Well, no. Well, first I want to see it myself because
Yeah, it's.
I never want to pass on confusion.
Yeah, because you're like at chart 50, but this was like in your first maybe 20 charts, I guess. I don't.
20 charts.
Yeah, it was more at the beginning when you were when you first mentioned MTT.
The first session.
Yeah, I was in the first session.
Okay. I won't go back.
No, you don't have to go
But I tell you what,
I'll write a note.
yeah. Make a note.
Okay, because I was going to ask you then, but.
Okay. Now, are you sure it wasn't mean time between failures? Because mean time between failures and mean time.
I know what between. I know what that
Okay.
is. I did
Okay.
capability, so I know what that
Yeah.
is.
Never mind. I can do.
Yeah, well, I'll write it.
I could actually.
I'll just
Okay.
do an action item for you.
Yeah. I don't want to.
Yeah.
Break the pace here because we're on a clock.
No, I'm good.
Yeah. Okay.
I'll just write it down for you.
Okay. All right.
Maybe I was wrong. I don't know, but.
Quick question on that mean time to restore function. An example would be that, like, if part of your golden dome or your constellation is lost, how quickly can you relaunch?
That's right. Oh, well, no, not how. Well, it depends on why you lost. Okay, because, for instance, there's the more frequent way of not being able to meet dependability, more frequent, okay, is when one or more spacecraft in a constellation go down. That's the more frequent way, okay? The less frequent way is when it goes down permanently, okay, and it has been replaced, which, takes longer, okay? Yeah, okay, so I just explained. I think I just answered your question, right?
Yeah, like permanent failure, I'd say that would be a critical failure.
Yes.
Physically lost.
Yes.
Mean time to restore would be like, how quickly could you replace it?
Right. And let's say, for instance, okay, let's say that a spacecraft goes into safe mode. Boom. Okay. Once it's into safe mode, it's not operable, right? So the objective is, okay, it enters safe mode, stays in safe mode until it can be restored. That's the right. Okay. However, okay, since all spacecraft that I know of, okay, have batteries, one of the risks is depth of discharge. Okay, so depth of discharge, if a battery reaches a certain point of discharge, it can't be restored. Right. So that becomes first it goes down, it might be considered a moderate risk or moderate hazard. If you can't restore it for some reason for the term, then now in that depth of discharge, because it's running on batteries, let's say you're raised on, okay, and then once you reach that point, now it becomes a critical, okay, and then once the whole satellite is dead, then it's catastrophic, okay? So it's important for you to be able to have a structured way to manage safe mode, and that's why safe mode should actually be owned by safety, not reliability, okay? Because if you can't maintain safe mode, then your vehicle becomes debris and becomes a damage risk for other assets. So it's not something. It's not just a mission. It's creating a damage risk for other assets. Okay.
Are you looking more for processes to handle those situations versus like specific root cause analysis or the specific failure points themselves versus we enter safe mode, we don't know why, but we're visiting like a critical failure, having a process documented to like form like my Tiger team to address this ambiguously defined issue.
Yeah.
Do you understand what I'm saying?
I understand what you're saying, but you also threw in two different ways in that conversation. Okay. Tiger teams, yeah, before they were super, everybody has a supercomputer the size of a phone, right? You just, had a bunch of experts, right? Some went down, you get your Tiger team, they figure it out, they do something, it saves the day. The systems got more complicated, you got supercomputers, now everybody depends on software, okay? You don't talk about a Tiger team anymore. Yeah, so, okay, what's the, okay, I just want to make, because you mentioned Tiger team and, so in the design process, the whole design, you're supposed to address this ahead of time, not let's launch it, then figure out what's going to happen. Okay, right. So you're supposed to think through the contingencies, okay, plot out the safe mode, okay, and also have programs on the ground in your ground station that address certain symptoms. They have to be symptom-based diagnostics, where when something, you've already predefined what the symptom is, you have the software to address that symptom, and then you can address all the risk, okay? So everything's ahead of time.
So you say you just need to demonstrate error handling capability.
That's right. Yes, that's what this depicts. That's why you have to have a process in place. Now, okay, now I'm getting ahead of myself, okay? In the old days, the only way you could do that, really, the only way you could do that is a fault tree, okay? In the old days, okay? Nowadays, you have more tools available. Okay, before we go, so we got the 5 minutes, okay? I just want to explain to everyone that there is actually a format that every safety, reliability, and quality assurance program complies with the same 7 essential elements, okay? Or they comply with the same general requirements, okay? So in this standard, okay, and these are S-102, these are S-102 requirements in the S-102 standards, okay? The first is to have the standard, the S-102 standards, okay, they should integrate with the company's existing command media, okay? So in order to comply with each standard, the company's, the supplier's existing command media needs to reference it, okay? The second one is to identify for every product, what the safety, reliability, and quality assurance requirements are for that product. In other words, you know, the spec requirements, statement order requirements, basically, all right? You have to determine or identify what those are. The next one is the plan. Okay, now for a safety engineer, especially a DoD, okay, the rest of them, except for the first one, the rest of them are basically also the same 8 requirements that are in 882E. They're essential. There's 8 in section 4, right? There's 8 essential requirements of every safety program, okay? These down here pretty much mimic them, okay? This one, it doesn't, all right? So the only difference between 882E and this set of standards is these 8 essential elements, well, 7 essential ones, apply to all programs, okay? The one in 882E only applies to system safety. You don't have this applicable to any reliability standards. You don't have this applicable to any quality standards, okay? Okay, now, I hopefully maybe somebody who's familiar with ISO 9000 will say, okay, I don't agree with you, but you got to prove it to me. Okay, safety 882E is the only one I know that has this, but in this set of standards, quality-based, this criteria applies to all disciplines, not just only safety. So have we reached?
Yep, we're there.
Okay. All right, well, I see you at 1 o'clock. Enjoy your lunch.